Okay, so question number 4. Question number 4. Oxalic acid, which is H2C2O42H2O, which has a molar mass of 126.07, is often used as a primary standard for the standardization of a sodium hydroxide solution. If 0.147 grams of oxalic acid dihydrate is neutralized by 23.64 milliliters of sodium hydroxide solution, what is the molar concentration of the sodium hydroxide solution? Oxalic acid is a diprotic acid, and what is the balanced equation? Okay, so let's write out the equation. If we had oxalic acid plus sodium hydroxide produces water and a salt, which would be sodium C2O4. Okay, so this is the neutralization reaction. And now we have to balance this equation. So we have 2 sodiums on our product side and only 1 sodium on our reactant. So we put a coefficient of 2 in front of sodium hydroxide. And now we have 4 hydrogens on our reactant side and only 2 on our product side. So we put another 2 in front of the water. Okay, so now everything should be balanced. So let's write down what was given. We have the molar mass of oxalic acid, which is equal to 126.07 grams per mole. And we also know the volume of sodium hydroxide that was used to neutralize. It was 23.64 milliliters. And we were also given the mass of oxalic acid, which was 0.147 grams. Okay, so the first step is to, let's see. Okay, so we're given the mass and the molar mass of oxalic acid. So the first step is to find the number of moles. So number of moles is mass over molar mass. And we have 0.147 grams and 126.07 grams per mole, giving us a number of moles equal to 1.17 times 10 to the negative 3 moles. Okay, so step 2 is to use mole ratios to find the number of moles of sodium hydroxide. So we know that we have 1.17 times 10 to the negative 3 moles of oxalic acid. And to find the number of moles of sodium hydroxide, we need to multiply by the molar ratios. So we can find this by looking at our balanced equation, and we can see that 2 moles of sodium hydroxide are needed to react with 1 mole of the oxalic acid. Okay, so we know we did it correctly if our oxalic acid moles cancel out, and we're left with moles of sodium hydroxide, which is equal to 2.34 times 10 to the negative 3. Okay, so now step 3 is to calculate the concentration of sodium hydroxide. Okay, so the formula for concentration is equal to the number of moles over the volume. So we know that we have 2.34 times 10 to the negative 3 moles of sodium hydroxide. And we also know the volume, which is 23.64 milliliters. But since the units for concentration are in moles per liter, we can convert this to milliliters by dividing by 1,000. So this is because there are 1,000 milliliters in 1 liter. Okay, so we get a final concentration equal to around 0.098 moles per liter. Okay, so now let's see what the junior tutor said. By definition, the law of conservation of energy states that mass is neither created nor destroyed. This is the basis for a balanced chemical reaction and equation, where the number of atoms present on either side of an equation is always going to be equal. The definition of molar mass is the mass of 1 mole of a compound, while molarity is the number of moles of a solute in a unit volume of solution. Here we have the equation for the molarity, which is equal to molar concentration, number of moles divided by volume. And here we have a balanced equation where the molar mass of oxalic acid is 126, molar mass of sodium is 40. And they said that the 126.07 grams is really needed for standardizing the 80 grams of sodium hydroxide. So they converted their units to mass instead of number of moles. And the given 0.147 grams of oxalic acid is used as a primary standard for standardizing sodium hydroxide. So they did a ratio where 0.147 divided by 126.07, so this is number of moles, or the mass of oxalic acid divided by its molar mass, and then they multiplied by 80 grams, which is the molar mass sodium hydroxide multiplied by 2 to get 0.933 grams. And then for molarity, they divided that by the molar mass of sodium hydroxide, and then divided by the liters to also get 0.098. Okay, so the answer is correct. It may be easier to find the number of moles to calculate the number of moles of sodium hydroxide using molar ratios. then calculating concentration.